Imaginary numbers extend the real number system so that square roots of negatives make sense in a controlled way. On the SAT, you mainly need the unit EI and a few algebra habits. If you memorize one fact in one cycle, most problems collapse into short arithmetic. We will build definitions, work 3 levels of examples, then lock in the fast patterns the test repeats. Define I as the square root of -1, then I squared equals -1. That identity is the engine behind every simplification. A complex number has the form a plus bi, where a and b are real. You treat I like a variable until you replace a squared with -1. Here a is the real part, and b is the coefficient of the imaginary part. Keeping terms grouped that way prevents sign errors when you add or multiply. Powers of I cycle every 4, I -1, -I, 1, then repeat. That cycle is your shortcut for huge exponents. After every 4th power you return to 1, because I to the 4th is 1. That is why modular arithmetic works on the exponent. Now practice the skills in order. Simplify a radical, multiply complex numbers, then collapse a giant power of IEI. Example 1, easy level. Simplify the square root of -16. Split is the square root of 16 times the square root of -1, which is 4a. Always pull the real square root out first, then attach I for the negative inside. This mirrors the rule for square roots of positive numbers. Split perfect squares from the radicand, then simplify the rest under the radical or beside it. Example 2, medium level. Multiply 3 plus 2i by 1 minus i. Use FOIL, first do outer inner lasso, the same as multiplying 2 binomials with real numbers. Expand 3 minus 3i plus 2i minus 2i squared. Replace I squared with -1, so minus 2i squared becomes plus 2. Combine like terms, 5 minus i. That is standard, form a plus bi with b equal to -1. Example 3, harder level. Simplify I to the 47th power. Divide 47 by 4. The remainder is 3, because 44 is a multiple of 4. So I to the 47th equals I cubed, which is -i. No need to multiply 47 copies. Remainders modulo 4 do the job. If you see I to the 0, remember any non-zero number to the 0 is 1, and I to the 0 fits the cycle as remainder 0. Common mistake, claiming I squared equals +1. That is the definition of real 1, not I. The correct identity is I squared equals -1. If you get a sign wrong, every multiplication afterward collapses. SAT pro tip, the powers of I repeat every 4. Divide the exponent by 4 and use the remainder to read off the answer. When you multiply complex numbers, always hunt for I squared before you combine like terms. That is where the sign flips hide. On grid-in questions, write a plus bi unless the problem asks only for a single part like the imaginary coefficient. Bonus pattern a plus bi times minus bai equals a square plus b squared. Conjugate pairs show up in denominators and in clever factorizations on harder items. Recap, 3 facts to keep automatic. First, I squared is -1, full stop. Second, multiply complex numbers like binomials, then simplify with the I squared replacement. Third, reduce giant exponents on I using remainder after division by 4. Practice more on NovaMaths.